In this video, we will go over a copy of the midterm preparation quiz. And remember that question 1 on the preparation quiz will include the formulas that you will see will be available to you on the actual proctored midterm exam. So remember, during the exam, if you need a formula, go back to the first question and you can see the formulas. All right, question number 2, fill in the blank with the appropriate word or phrase. A system of numeration in which the number 1, 2, 3 is written is which system? And that system is the system that we use, which is the Hindu-Arabic system. Using the table, write the given Egyptian numeral as a Hindu-Arabic numeral. So if we notice here, it starts out with the pointing fingers, and there are 4 of those, which is 10,000 or 40,000. And then we see 4 of the symbols for, we don't see any 1,000 symbols, but we see 400 symbols. So we're going to have 4, 0, and then we're down to the hundreds. We see 4 of those. And then we see 4 of the heels. And then we see 4 of the single shafts. So it's 40,444. Write the Hindu-Arabic numeral for the given numeral from the Roman numeral system. So when we move from the left to the right, we first see a symbol for 1,000. So we're going to start with 1,000. And then we see a 100 in front of, or to the left of a 1,000, which means we're going to subtract 100 from 1,000. And we've got now 1,900. So we're at 19. And then we go on and we see, next we see an X to the left of an L, which means take 10 away from 50, which gives us 40. So now we've got 1,940, and then we're finally finished with a 5, so it's 1,945. Write this symbol, the numeral below, as a Roman numeral. So we see a 3, so we know we're going to have XXX, X, 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 and then we need a V for a 5. Okay, for number 6, we're writing this number as a traditional Chinese. So we see 745. So we know we're going to start up the top. We write these vertically. And we see the number 7, and that's a 7 times 100. And if I look in my symbols here, here's the symbol for 100. First, I know I've got to have 5 different symbols shown here. So I can eliminate answer A and B because they don't have 5. They've only got 4. And if you notice, we're going to take them 2 at a time starting at the top. And we notice this one looks to be the only one that could be correct. If I start at the top and move down, I've got a 7 over the symbol for 100. 700, and then I see the symbol for 4 over the symbol for 10, that gives me the 40, and then I see a symbol for 5, so the correct answer here is D. And now we're into the Ionic Greek, and they want us to write the number 239 in that system, so we look for the symbol for 200, and we see it's right here, and we look for the symbol for 30, which is right here, and then the symbol for 9, and if we look in the answers, we see it must be the third choice. Fill in the blank with the appropriate word or phrase. The base used in the Babylonian system is what? In that system, the base is the 60 rather. And then we're going to write this number in the expanded form, and the number is simply 12. So we see here we've got 1 times 10, and then we've got 2 times 1. And now we've got a Babylonian, and we only have 1 grouping of symbols here, so that's going to be the single digits, and those are the little daggers, and that's just going to simply be a 3. All right, so for number 11, I'm going to go over to what I call a detailed solution. And what we have to do here is we want to write a number in our system in the Babylonian systems, and we have to worry about the positional values. And if you remember, the base is 60, so the positional values are 1, 60, 60 squared, and so forth. So the largest positional value less than our number is 60. So I'll take 306 and divide by 60, and I get 5 with a remainder of 6. So I need 2 groupings, and on the left side, I need symbols to show 5, and then the next grouping for the single units, I need symbols for 6, and I see that in answer number C. So the answer for this one is going to be letter C. And I'm going to stay right over here because the next one is going into the Mayan system. And we have 3 groupings here, and we know the positional values in the Mayan system are 120, and then it's 18 times 20, which gives 360, and then 7,200. And so the top one here is going to be the positions for the 360, and we see a symbol there for 3. So I've got 3 times 360, or 1080. And then the next position down is the positions for the 20s, And I see a symbol there for 16, so 16 times 20 is 320. And then in the single digits, I see a symbol for 14, and if I add those three numbers together, I get 1414. And let's go back over here, because these I'm going to do on this side. So write the symbol as a Mayan, and the Mayan symbols are right up here, and 100. So that, remember, the largest positional value less than this number is 20. So if I divide 20 into 100, what do I get? I get a 5. And the symbol for 5 is simply this, the line. And so the answer here is going to be B. In the numeral 815 base 6, the 6 is called the, and I just said the word, it's the base. And I want to convert this number back to our system. And I can't remember if I have a detailed solution for number 15 or not. Yeah, I do. Okay, here it is. You want to write it in expanded form. So 354 base 7, and I've got 3 positions there. So I've got 1 7s and 7 squared. So I have 3 times 7 squared plus 5 times 7 plus 4 times 1. If I go ahead and simplify, I come up with an answer of 186. Now I want to go the other way, from our system to base 6. So the positional values in base 6 are 1, 6, 36, and 2, 16, and so forth. So I'm going to divide 178 by, I should say 36. 36. And I get 6 remainder 34. Then divide the 34 by 6 to get 5 remainder 4. And then divide 4 by 1 to get 4. So the number is 4, 5, 4. 4, 5, 4 in base 6. Okay, and here's a definition here. Use the following diagram and assume that the ratio AB to AC is equal to the ratio AC to CB. And what do we call that proportion? It's referred to as the golden proportion. Determine whether the sequence is a Fibonacci type of sequence, and if it is, determine the next 2 terms. So remember, in a Fibonacci sequence, a number in the sequence is the sum of the prior 2 numbers. So we have -7 plus 4 would give us -3. 4 minus 3 would give us 1. 3 minus 1 would give us -2. And if we keep going and we take 1 minus 2, we would get -1. And then -1, and it would be -1. And then the next 2 would be, go on here. It's going down by, I think that's correct. I might have made a mistake. Hold on, just let me check my answers because I'm just looking at that. Yeah, it's D. It's D. Okay, which of these is the golden ratio? So this is just a definition question, and the golden ratio is C. And another definition question. To determine the value 43 is congruent to in modulo system, what do? We divide by 43 by 7 and determine the remainder, which is the first answer. Okay, this problem here is in a modular system, so I'm going to go over here, and it says, if today is Wednesday, determine the day of the week it will be at the end of 475 days, no leap years. Okay, so take 475 and divide by 7, and you get 67 remainder 6. And then count 6 days ahead, and that would take you up to a Tuesday. And let's stay over here. So we're going to be in a modulo 12 system on the months of the year, and we want to know where we will be in 76 months if it's currently July. So take 76 and divide by 12. You get 12 remainder 4. Count 4 months ahead from July. That would be August, September, October, and it would go up to November. Okay, find the modulo system to which the number belongs for the given system. So we have 95 modulo 6. And so what do we do here? We take 95 and divide by 6. 95, divide by 6. And remember what we want to do? We want to get the remainder. So if we take 95 and we divide by 6, sorry, doing this offline. I didn't work this one ahead of time. 95 divided by 6. And we get a remainder of 5. Comes out to be 15, remainder 5. So it belongs to the mod class, the 5 class. To change a decimal number to a percent, multiply the decimal number by 100. Oops, 100. Oh, it's a multiple choice. Sorry, I didn't see that. All right, and this one we have a graph here. Get back to my other detailed solution. There we go. Okay, so the graph shows the percent of employees who take time off during 1 year because of colds. The company has 8,310 employees. Use the graph to find the number of them who miss work for 1 or 2 days for colds. So if we look in the table, we see 24% of the employees miss work 1 to 2 days per year for cold. So if we take 24%, change it to the decimal, multiply by 8,310, we get 1,994. So you're going to round off because we're talking about people. So it's going to be 1994. Okay. So this is a percent change question. So enrollment in a business seminar increased from 51 to 75 people. What was the percent increase? So remember, we take where we are now minus where we started from and divide it by where we started from. So 75 minus 51 divided by 51 and then multiply by 100. And so I come up with an answer here of 47.1%. Fill in the blank with an appropriate word, phrase, or symbol. The money the borrower pays for the use of the lender's money is called, and that's, remember, the borrower is paying that, that's the interest. And now we've got a couple interest rate calculation problems. So let's take a look at this one. This is a simple interest problem. So we've got principal is $490, interest rate is 7.25%, and the time is 4.75 years. And I put those into my simple interest formula, I equals PRT, and I come up with a simple interest of $168.74. Same thing on number 29, simple interest formula, except this time we want to solve for the interest rate. So we're given the interest, we're given the principal, and we're given the time. So I went ahead and substituted those into the formula right here. And then I'm going to simplify on the right side, multiply 6435 by 3, divide by 12. I get 1608.75. Divide both sides by, I should say 1608.75. And I come up with an interest rate of 6.5%, which is answer B. Okay, this one here is where we're figuring out the number of days between two dates. So they want us to know the time from February 3rd to October 20th. So I went ahead and I looked up October 20th in the table, and if you go down here to October 20th, you'll see it's day 293, and then February 3rd is day 34, and I subtracted and I got 259, but notice this is a leap year, and you notice there's a little note down here, add 1 day for leap year if February 29th falls between these dates, which it does. So the answer here is going to be 260 days between these two, 260. And let's go over to the detailed solutions, one on this one. So Alan's borrowing $4,400 from his father to buy a car. He repaid after 8 months with an interest of 7%. Find the total amount he repaid. Assume simple interest is being calculated. So we'll use the simple interest formula to find the interest. Principal is $4,400, 7% interest rate. He borrowed for 8 months, so the time is 8 over 12. So I came out with an interest of $205.33. How much does he have to pay back, though? He has to pay his father back the interest plus the principal, so the total payment back to his father is going to be answer B, which is $4,605.33. Fill in the blank. The effective annual yield or annual percentage yield is a simple interest rate that gives the same amount of interest as a blank rate over the same period of time, the same as a compound rate. And now we're going to do compound interest formulas. So I'm going to skip over to my detailed solutions here. And we're going to do a compound interest here. We're borrowing $9,500 we're accumulating interest for $9,500 for 4 years at 7% compounded daily. And notice they say use 360. Now, the difference between the compounded and the simple interest, in the compounding formula, you get the accumulated amount. And to answer the second part of the question, we're going to have to subtract off the amount we invested in order to find the interest. So I use the compound interest formula with the principal of $9,500, interest rate of 7%, 360 compounding periods, and it was in for 4 years. So I put those numbers into the formula, and I went ahead and I simplified the exponent right up here. And then from here, I'm going to go ahead and simplify inside the parentheses here. I took 0.07 divided by 360, add 1, raise it to the exponent. In fact, I can pull my calculator up here and we can do this all together. So I put in 0.07 divided by 360 plus 1. And then I'm going to raise it to my exponent, which is 1440. And then lastly, I'm going to multiply by the amount that was invested, which was $9,500. And so the accumulated amount is going to be $12,569.39. And then in order to find the interest, I need to subtract off the amount that was invested. So the interest is the difference. And you see down there, it's $3,069.39. And the next problem is an annual yield problem, and we use the formula that was given, and we're going to invest $1 for 1 year at 4.2% compounded quarterly. So again, here's my formula. I start in my calculator, take 0.042, divide by 4, add 1, raise it to the 4th power, subtract the 1, and then we always multiply by 100 at the end, and they want it to the nearest hundredth, so this would be 4.27% for the effective yield. And now we're going to do a present value. How much do we need to invest now in order to accumulate a certain amount? So we want to accumulate $70,000. Interest rate is 2.2%, compounded monthly for 12 years. Here's my numbers in my formula. And let me go ahead and pull up the calculator, and we can do this one together. So I'm going to start down here, 0.022 divided by 12 plus 1. And then I'm going to raise that. 12 times 12 is 144 to the 144th power. Now my calculator has a storage option, so I'm going to go ahead and put that in storage. And I'm going to put in the 70,000, and I'm going to divide by, I'm going to pull that number back from recall. And so I come up with $53,771.14. Let's go back over to the other one. Fill in the blank. The true rate of interest charged for a loan is called the, so for number 36, what would the answer be there? That would be the annual percentage rate. All right, and then let's go over to the detailed solutions for the next one because we've got another formula to use here. So we're going to find out what the monthly payment is here if we borrow $17,000 at 4%, compounded for making 12 payments a year for 5 years. So here's my formula. Now, important to notice on this one, there's a negative in the exponent here. You want to make sure that you catch that negative exponent. So let's pull up my calculator, and I'll simplify the numerator first. So I take 17,000 times the 0.04 and divide by 12. And that's where I got the 56 point, if you see right here, 6666667. And then I think I will, well, I'll just write that one down for now. So let's go into my numerator, my denominator rather, and I see that I've got 0.04 divided by 12. Pull this over here, make sure you can see it. Divided by 12. Oh. Plus 1. And we're going to raise that to the negative 60th power. Now, in this calculator, you put the number in and then you negate it. Okay, so I've got 0.89, which is what I showed over here. And now I'm going to put this in storage. And then I'm going to say 1 minus memory recall. And that's where I got the 0.18099, etc. right there. I'm going to put that into storage. And then I'm going to put in my numerator 56.6666667 divided by memory recall. And so I come up with 313.08. So that's my monthly payment on that particular mortgage. Let's see. So Meredith needs a new roof on her house. The cost is $2,800. She's going to finance it by putting 25% down, and the balance will be paid in 36 payments of $66.78, and we want the finance charge. So how much did she borrow? She borrowed 75. She put down 25%, so she actually borrowed 75% of $2,800 or $2,100. How much did she pay back? So take the monthly payment, $66.78 times the 36 payments, and we see she paid back a total of $2,404.08. Subtract the amount financed, and we come up with what her finance charge was. It was $304.08. Now this time we're going to do the same thing to find the finance charge. So we're going to take the number of the amount of the payment, 300, times the number of payments, 5,400, subtract the amount financed to get the finance charge. Now, to find the APR using a table like this, you take the finance charge, divide by the amount you financed, and multiply by 100. And you get what we call the multiplier, 4.854. So you look in the row for 18 payments, and you find the closest value to that, and the closest value happens to be there, so the APR was 6%. Okay, Xing's credit card company determines his monthly payment by adding all new interest to 1% of his outstanding balance. And they have an interest rate per day, which is shown there. And on March 15th, he uses his credit card to buy airline tickets for $2,500. He makes no other payments during March. Use the information and the rule that minimum payments are rounded to the nearest dollar to answer parts A and B. So what's his minimum payment going to be in April 1st? So he charged $2,500, and he has to pay 1% of that. So $25 is due on April 1st. Now, say on April 1st, he makes more than the minimum payment. He actually also sends in an additional payment of $700. So we're going to take that $700 and apply it to the principal. And so we're now down to $1,800. So on May 1st, he's got to pay 1% of that, which is $18. But he also has to pay the interest for 30 days on the $1,800, which comes out to be here 23.02, which rounds up to 24. So he's going to have to pay 18 plus 24 or $42 on May 1st. This percent change problem should have appeared a little earlier. I apologize, it's a little out of sequence, but this goes back to actually section 10.1, but we'll go ahead and do it anyway. So Juan went on a diet and he lost weight. He's down to 249 when he started at 268, and we want to find out the percent decrease in his weight. So 249 minus 268 is 19, and divide by 268. So it's a decrease of negative 7.3%. Now notice it's a decrease described here. So when you put the answer in, you're only going to put in the 7.3. You're not going to put the negative in front of it because it's being described as a decrease. Fill in the blank. The buyer's gross monthly income minus any fixed payments with more than 10 months remaining is known as the buyer's what? And that's known as the buyer's adjusted monthly income. All right, now we're going to go over and do a mortgage payment where we're using a table. Okay, so what do we do here? This table lists the amount of interest and principal for $1,000, and we want to finance $95,000. So we take 95,000 and divide by 1,000. So we see there's 95 units that we're financing. And then we look in the table at the 5% row, and we're doing 15 payments. So the 5% row, there's the multiplier that we're going to use, 7.90794. And we multiply that by 95, and so we get a monthly payment of $751.25. This is a down payment problem. The Morgans are buying a home for $715,000. The bank requires a down payment of 20%. What is that down payment? So 20% of $715,000 is $143,000. Fill in the blank. A retirement savings plan where employees of a private company can make contributions pre-tax dollars that are pooled with other employees is called what? And that's a 401k. All right, and then we have some more detailed ones for the last couple of problems. So number 47, use ordinary annuity formula to determine the accumulated amount in the annuity. So we've got a payment of $125 monthly for 8 years at 8% compounded monthly. All right, so here's our formula. And so what I would do here is probably simplify the denominator first. That's pretty easy. Let me go ahead and pull the calculator up. So we've got in the denominator 0.08 divided by 12. And so I've got 0.0066667, which is what I showed down here. And then we'll go ahead and we'll work on the numerator. So we've got 0.08 again. That's what I just did. I'm going to add 1 to it, so plus 1. And then I've got to raise that to the 12 times 8, which is the 96th power. So raise it to the 96th power. Right? And then we subtract 1. And then we multiply by the payments, 125. And then I divide by that 0.006666667. And I come up with $16,733.57 would be accumulated. Another annuity problem, same sort of steps there. I'll let you work through these, but this one you come out with a total accrued of $11,145.34. And then finally, this one here, same kind of problem. How much is going to be accrued? Same thing. Monthly payments of $500 for 14 years, and they're going to accrue $161,963. And then one last one in. This is figuring out, this is the monthly payment invested. So we've got here the sinking fund formula here. How much do we have to put in each payment period? And we're doing this monthly. So again, we put the numbers into the calculator, very similar to what we did before. Simplify the numerator. Go ahead and work on the denominator here, 0.05 divided by 12, add 1. Raise it to the 408th power because it's 12 times 34. Subtract 1. Divide that into the numerator. And so you come up with a payment monthly of $430.26.